Alright, so far in Trig, we've been talking about trig functions and how you can find, based on your unit circle, finding an x value, a y value, finding cosine or sine, respectively. What we're looking at today, though, are things called inverse trig functions, which just means working backwards. So, we did before, sine of pi over 3 means at pi over 3, what is the y value? Root 3 over 2. Same with all these other guys. 5 pi over 3, so it's negative root 3 over 2, and so on and so forth. What we're looking at today, though, is if I were to work backwards, if I took the inverse sine of a number, so say like root 3 over 2, I could also call the same thing as saying the arc sine of root 3 over 2. It means the same thing. What that means is, at what value, at what angle, does sine equal root 3 over 2? Well, as you can tell over here, we actually have two different values where that's true. Because remember, we said your calculator will lie to you if you just typed in the inverse sine. You could have two possible triangles. So that's why the inverse sine or the arc sine has two different possible values. Now, what we will use this for, let's try to figure out a couple of them. If I do arc sine of root 2 over 2, well, here's the way that I would look at it. First off, I know I need sine being positive. That happens in quadrant 1 and quadrant 2. In quadrant 1, when does sine equal root 2 over 2? That's right here at 45 degrees. So 45 degrees, or I could say pi over 4, is my answer in quadrant 1. So that's one of them. This quadrant 4 actually acts as my reference angle. So the question is, what is pi over 4 in quadrant 2? Well, pi over 4 in quadrant 2 would be how much more to get to a full pi. So 3 pi over 4 is my other angle, where I have sine equaling root 2 over 2. And that should make sense, too, if we looked at it, because there's root 2 over 2 as the sine value. So number 2, arctan equaling root 3. Tangent is positive in quadrants 1 and 3. So what I need to find is my reference angle, where in quadrant 1 do I have tangent being square root of 3? Well, it can't be 45 degrees, because that'd be root 2 divided by root 2. Remember, tangent is y divided by x. That would be a value of 1. If I did 30 degrees, that'd be 1/2 divided by root 3 over 2. That's the same as saying 1/2 times 2 over root 3, which would be 1 over the square root of 3. So that's not what I want. If I did it 60 degrees, though, the other way around, root 3 over 2 divided by 1/2. Same as root 3 over 2 times 2 over 1, which gives me the root 3 that I need. So my reference angle here is at pi over 3. I need to know what pi over 3 is in quadrant 3 as well, though. Okay, that would be down here, pi over 3 going backwards, so that would be 4 pi over 3 as my other angle. And again, I should have the same values that I would be dividing in that case. A couple more examples to look at here. Arc cosine of 1/2. So when is cosine, the x value, equal to 1/2? Well, in quadrant 1, that's again here at pi over 3. But I also need to know the other place where cosine is positive. That's in quadrant 4. So in quadrant 4, pi over 3 here would be the equivalent of 5 pi over 3, or 300 degrees if you're doing it in degrees. So those are your two answers. And again, you can find that just by looking there at the x values if you know the entire unit circle as well. For number 4 here, arc secant. Well, I don't like secant, so I'm going to change this. I don't like secant. I know that secant, though, is the flip of cosine. If I flip the trig function, though, I better flip the number as well. So where is cosine equal negative 1/2? Well, I can do this two ways. I can either look, need to figure out exactly where this is. I can go and see, well, cosine, the x value equaling negative 1/2 is right there, and also right here. I can go that way, or I can say, well, first off, in quadrant 1, for my reference angle, where is cosine equal to positive 1/2? Well, that's right there, again, at pi over 3 for an angle. Or if I want to go degrees, that'd be 60 degrees. What I'm looking at, though, is now cosine being negative. So quadrants 2 and 3, those are the quadrants cosine is negative in. So I need to know what pi over 3, or 60 degrees, is in each of those two quadrants. So in quadrant 2, pi over 3 going backwards would be right here at 2 pi over 3, which is what I had circled anyway, because I knew that was negative 1/2. If I go in quadrant 3, so going down an extra pi over 3, that'd be 4 pi over 3, again, which I had already circled because I already knew that had to be the case. Alright, 7 and 8, they look ugly, but they're pretty straightforward what we have to do. Okay, just like we began before, we need to say, start on the inside. What is the arc sine of root 2 over 2? Well, y equals root 2 over 2 at two places. At 45 degrees, I'll even do these in degrees just to be a little different, and 135 degrees. So here and there. What I need to do though now is I need to take tangent at each of those values. So at 45 degrees, what is tangent? Y divided by x is just positive 1. Y divided by x at 135 gives me a negative 1. Maybe you see a pattern kind of forming already. Number 8, the arc cotangent of 1. That's the same as saying the arc tangent of, well, the reciprocal of 1 is also 1. So where does tangent equal positive 1? Well, that should happen in quadrant 1 and 3. That's at 45 degrees and at 225 degrees. So what is the cosine, the x value at each of those numbers? Well, again, a little pattern here. Cosine here is root 2 over 2. Cosine in the other one is negative root 2 over 2. So each of these you have the same number, just one's positive, one is negative. Now here, let me give you a different way you could have solved this same triangle, or this same trig value. You can do it by drawing a triangle. If I draw a right triangle with an angle, and I'll call it theta, I want sine of this angle to be root 2 over 2. That's what that's saying. Well, sine means opposite over hypotenuse. So root 2 is the opposite, 2 is the hypotenuse. I can figure out what my missing side here is by doing a squared is my missing side, plus root 2 squared equals my hypotenuse squared. So a squared plus 2 equals 4. That means a squared will equal 2, or a equals the square root of 2. Alright, and also remember, when you take a square root, you normally should have to put plus or minus. So that's why my value here is going to be plus or minus square root of 2. Because now what I have to look at is what is the tangent of the angle. Tangent is opposite over adjacent. So it's going to be root 2 over 2, which is 1. And like we said, they all have two answers, positive 1 and negative 1. So two possible answers for that triangle. If I do the same thing for this one, if tangent is equal to 1, that means opposite over adjacent must be 1. I'm going to do the same thing. A squared plus b squared equals c squared. I know that a and b are both 1. So that means 2 equals c squared. That means c equals the square root of 2 again. Okay, so what I'm going to look at now is the cosine of this angle, or the adjacent over hypotenuse. So my answer should be 1 over the square root of 2. That's the same as saying the square root of 2 over 2. And again, plus or minus, because when I take a square root, it should technically be plus or minus. So plus or minus root 2 as your possible answer. So whether you like doing it with the triangle or using the unit circle ideas, either way works just fine for doing these inverse trig functions.